Yo, welcome back to part 9. The big thing we're talking about today is the player death state or failure state. So basically just a game over. And we also start working on the HUD. And in this one specifically, we're going to make the player's HP look nice in like a really easy, cool way. I also mentioned some stuff on game resolution. So this should be a somewhat mundane, but also very productive one. So yeah, good luck. Okay, it's a new day, new recording session, ready to get started where we left off, which I believe was adding in a fail state to our game, ergo a game over for our player. So let's just get right in there. Let's open up our player object, and we're gonna want to go in the step event. And look at all this stuff we have. Okay, I'm gonna minimize a bunch of stuff, get everything closer together, just right there. Okay. And we could put our death state pretty much anywhere. And by death state, I just very simply mean that we're just gonna destroy the player character whenever their HP is less than or equal to 0, just like we do with our enemies. And so let's just go ahead and put it at the very bottom. So we'll just call this death. It's gonna be really simple, or death/game over. We're gonna say if our HP is less than or equal to 0, then we destroy ourselves. So we call instance destroy. This works pretty well at the bottom of the step event, but at the point that our player has less than or equal to 0 health, it doesn't really make a huge difference where we do this. The main thing that you want to know is, and to be honest, I'm pretty sure I know how this works, but I feel like sometimes maybe it doesn't happen. But let's say that instead of having our death code here, we just put it right where we were getting damaged. So, keeping all of our health related stuff in one section. Sometimes, and by sometimes, I think I mean most of the time / every time. It's kind of hard to tell, but in GameMaker, if an instance destroys itself like this, and then anywhere below that code, there is a reference to this own object. So for instance, let me go here. Okay, right. So down here when we're shooting the weapon, we directly reference the player with the keyword other over here to get the player's aiming direction, to set the bullet to the right direction. And maybe it depends on whether or not I'm trying to get the specific ID of the player. I'm not sure if it works with the keyword other, but if the object were to destroy itself over here and it were to get referenced over here, I think maybe this would return an error because GameMaker actually oddly wouldn't know what other is referencing because we've technically destroyed ourselves up here. Maybe the keyword other would be fine, but I feel like if we did it this way where we stored our ID in a variable like this out here, and then we referenced it this way, this would do the same thing code-wise, since we're storing our own specific identifier and then we're checking our identifier. Maybe instance destroy frees up our identifier. I'm not totally sure. But like I said, sometimes that can give you issues, and it can also potentially give you issues for stuff in the future. So, anyways, my point is, anytime you kind of destroy yourself in an object and you have a lot of code below that, you probably want to call that exit keyword that I was talking about, where once we would destroy ourselves, now we won't run anything down here. So if you want the death code up here, you should probably do that, or you can just do what we did at first and just put death code at the very bottom. I think I'm just going to keep it at the very bottom. So anyways, let's test this first. This code is extremely simple, so it should work. But what we're testing is actually something else. So first, I'm just going to set the player's HP to be really low. I'm going to set it to like 2, so that way I can make sure we're getting hit at least once, and then the next time we're hit, we lose. So test that really quick. Get hit by an enemy just by running into him, and then I can let a bullet hit me. Okay, so my player was destroyed, and I can't do anything else, which is fine. If you followed the video closely, you should not be getting an error right now. And the error that you could potentially be getting would be if the player was destroyed and some object is looking for the player and referencing it in their code, like the enemies or the bullets, but you did not put in the check to check and make sure that the object player existed before you did any of that stuff. So if you're getting an error, that would be the problem. Look at your error window. You'll be able to read it. It should tell you what object is looking for object player, and it should say, something along the lines of, instance does not exist, or cannot find instance of blah, 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 that kind of thing. So if that's the case, you just need to go into that object and go into the line of code that it tells you. It should be telling you specifically what line you had that written in. And anywhere that you're referencing object player, you need to first add in the check if instance exists object player, and then do it. If you're following along with the video, you shouldn't be getting that error. So I'm just going to move on. And like I said, if you did, your the error you'll be getting will tell you where it is. So go fix that and then test that, get back to this point. And then yeah, we're ready to add some more stuff. First of all, you can see that all the enemies are shooting the bullets to the right because the bullets don't have anywhere to aim, so they're just starting at direction 0, but that doesn't really matter. Okay, so yeah, so the player death works fine, which is good. Now we basically need an object that gives us like a game over screen and lets us restart the game. So that won't take too much work. Let's get started on that. So if you forgot what the game over screen looked like in my little demo there, here's a short clip of it. And basically what it does is it fades in, says game over. It's kind of see-through, so that way you can see stuff still happening. I think that's kind of cool. And that tells you to press a button to restart the game. And then whenever you do press the button, it will restart the game. And if you want a fully black game over screen, that's fine too. This system works exactly the same way for that. So cool. I'm going to add this to my game control folder just because that kind of makes sense to me. So I'm going to right click and create a new object. I'm going to call this O game over screen like that. And let's add some variables in our create event first. So our first variables are just going to be for the fade in. First, we want to have an alpha value, which is opacity, and we want to start that at 0. So it starts clear and then fades in. So we'll start that at 0, and then we'll have our alpha speed. And this is going to be basically, we're going to calculate this by determining how many frames we want it to take to fade in. So if I wanted it to take, for example, 75 frames to fade from 0 to 1. So that means every single frame I would want to add 1/75th to the alpha, right? Makes sense. So over the course of about 1 1/4 seconds, the alpha will go from 0 to 1, which would be totally opaque. So totally black screen. And then we can add a third variable if we don't want it to be totally opaque. An easy way to do that would be to add a alpha max. You can call this like alpha max or alpha multiplier might be better. So alpha mult, something like that. But if you don't want it to be 1, which would be fully opaque, you can pick another value. I picked 0.6, and we're not going to clamp alpha to alpha max. Basically what we're going to do is we're ultimately going to set the alpha to be alpha times alpha max, which means that now over the course of 75 frames, our alpha will tick up to 1 times 0.6. So that's how I'm going to do that. You can either ignore this variable if you want it to be fully black, or you can just set this variable to 1. And that's all the variables that we're going to need in this object, so that's pretty great. But finally, we want to make sure that our game over screen draws on top of everything else. So let's set the depth to a really low number, and I'm going to do -10,000. That way that gives us room to put our HUD at say like -9,000 or something like that. And this will always draw on top of everything, which is what we want, at least in this case. And really quick, I just want to mention that before we go into the step and draw event, I want to mention this event here that some of you might already know about and might be thinking about, and that's the draw GUI event. A lot of times people use this event for drawing stuff like the HUD. Basically the GUI or the GUI layer is like a separate thing from your regular drawing. So your GUI layer happens after everything in the other normal draw events. So people use it for HUD a lot of times because it just naturally draws on top. You don't actually have to set its depth to anything because it's just a single layer. It also gives you effects that you might see in a lot of games, like something like Celeste comes to mind immediately, where the game is in a pixel art style, but when you get to the text boxes, you have very pristine fonts and character portraits that are hand-drawn and non-pixel art. A lot of times that's how you get that sort of dichotomy in certain retro style games, they're using that GUI layer. I'm cutting out the part where I just sort of rambled for a few minutes about the GUI layer. The point is, I'll talk about it at some point in the future, maybe in another video or something like that, but the point is, I just prefer to use the draw event for this project and a lot of projects. The main reason being that the draw event stays at the same resolution as the game, where the GUI event doesn't. It takes the resolution of your monitor, as I already showed off, but for this project, I like to keep everything the same with the resolution, and the GUI layer just works a little bit differently. So in my mind, it's just a little bit easier to stick with the draw event for now. Okay, anyways, back to the video. So anyways, I was just mentioning that for people who might have been wondering why we weren't using this layer and why we would be using the normal draw event, but that's why. So we're using the normal draw event, which means we need to set our depth to be very low so it draws on top of everything. So cool. First we can go into our step event. So let's add one of those, and this is going to be the fade in code, and it's going to be very simple. We're just going to add the alpha speed to the alpha, and then we are going to clamp our alpha variable between 0 and 1, like that. Easy. So now we have an alpha variable ready for our drawing, so we can go to our draw event. So open up our draw event, and the first thing we want to do is draw a black rectangle over the screen. And to do that, we first need to get our camera coordinates because we need to draw it, where the camera is. So first I'm getting my X here, just like we always have been, using camera get view X or view camera 0. Then we need to figure out, the right side of the rectangle, which means we're gonna have our X, and we're gonna have our width. So camera W equals camera get view width. So yeah, getting our view Y and our view height as well. So first let's draw our rectangle. So draw, you can do draw rectangle color. And the way this works is we're just going to input 2 coordinates. We're first going to input the top left of the rectangle and then the bottom right of the rectangle. And obviously GameMaker just figures it out and draws it from there. So our top left is obviously just going to be our camera X and Y coordinates because that's the top left of the screen. So camera X and camera Y. And then our bottom right is going to be those plus the width and the height. So for our second X coordinate, we need the right side of the screen, and that's going to be cam X plus our cam W. And then the bottom of the screen is obviously our camera Y coordinate plus our camera height, like that. And then we have some colors to input really quick. Interestingly enough, draw rectangle color allows you to input 4 different colors, 1 for each corner, and then they sort of fade into each other. So if you did want to do something a little bit more fancy, you could, but for now, I'm just going to do all black for each corner, which will obviously just give us a full black rectangle. So now we got the colors right, and then we have one final argument, which is, it says down here, it says outline, and this is just basically asking if this rectangle is just going to be the edges. So if it's just going to be an outline. We don't want it to just be an outline. We want this to be a full colored in rectangle. So we are going to set outline to false. And before we add anything else, we can go ahead and just drop our game over screen into our room. So I'm going to drop it on an instance layer. There we go. And it should work out fine for us. And it should just be a black screen, really. Okay, it's working because all we're doing is we're just drawing a solid black rectangle across the screen. Great. So normally whenever we do our drawing functions, if we want to have alpha value or an opaqueness, normally they're built into the drawing functions. And obviously this function doesn't have a space for our alpha, but that's okay. We can manually set the drawing alpha of the game with a certain function. So let me show you what that looks like and what that means. So this is called draw set alpha. And like I said before, alpha ranges from 0 to 1, where 0 is fully invisible and 1 is fully opaque. Draw set alpha changes the setting for your game itself. So normally it's almost like this function, draw set alpha, is always being set to 1. And that 1 is basically kind of a multiplier. So naturally anything using a draw event will draw it at its full alpha unless we specify otherwise inside of a function or something like that. But we can manually set it to something here, such as our alpha value. So we set it to our alpha value, and what this will do is anything drawn after this point, and I don't just mean in this object, I mean anything drawn after you've set this draw set alpha will now be set to this value right here, this alpha value in any object. So we only want to affect our rectangle here. So after we've drawn this, we can draw set our alpha back to 1. That's very important. Anytime you change draw set alpha to something like this, always have to change it back. So if I were to run the game now, here's what it would look like. It should just, yep, it fades in like it's supposed to. So that works. Let me show you what it looks like if I just change this and don't change it back to 1. So I'll even get rid of the rectangle. And what's basically going to happen is I believe the enemies and the player will probably still be drawn, but there might be a couple other things that sort of fade in. And the reason that the player and the enemies will still be drawn is because we're calling functions and setting the alpha in there intentionally. But pretty much anything that's just using a default drawing function will kind of fade in. So let's see if there's anything to see. Okay, yeah, so you saw all the health bars for the enemies are being set to that alpha value. They have to fade in as well. And I think the crates do also. Let's see. Yeah, the crates also fade in. So yeah, so that's why it's very important to set this back to being 1. And then our next thing is our fade in is going totally opaque, which is not necessarily what we want. So, you know, like I talked about over here, now we can just multiply our alpha times our alpha max whenever we're setting it right here. So this isn't just going to be alpha, it's going to be alpha times alpha max. And so now it should look like this. Yeah, look at that. Okay, and so this is where it gets. And our player got mobbed anyways, and so now it's starting to look a little bit more like your game over screen. So cool. Easy peasy. So we've drawn the rectangle, and now we just want to draw the text. I'm going to set this out here. And first what we're going to do is we're just going to use GameMaker's default font, which might look a little bit plain, but that way we're all on the same playing field here. And then afterwards, I'll show you how to add your own font. So first we want to type our game over text. So let's just do that the easiest way first. So we'll just use draw text. We want to type it in the middle of the screen. So that's going to be our camera's X position plus half of our camera width, right? And that's going to be the same with our camera Y. So it's going to be our camera Y plus half of our camera's height. That'll give us the center coordinate in the screen. And then we want to type in game over for our string. So first, let's see how that looks. Well, very wrong, actually. Well, and that's because I put camera height over here instead of camera width. So let me fix that really quick. Like I said, it's very important to get these right, because then you'll get weird stuff like that. Okay, so still doesn't look totally right, but we can see that the text is at least starting right here, which is the center of the screen. So a couple issues. This isn't fully centered. The text is a little small, and it also doesn't fade in. It just is already there. See? The background fades in, but the text doesn't. So first, let's center the text. And we can use that doing these two functions. So draw set H align, and we have draw set V align. So that's draw set horizontal alignment and vertical alignment. And if I open up one of these and I bring that window over here. So again, I just middle click on a function to have GameMaker open up the manual for me. So you can read it like this, and it just shows you how the alignment works. So if you type in these constants, it can set the text to be centered on the left and then type outwards that way, here in the center, and the text types outwards in both directions, and then right where it types to the left. So very useful, very cool. At default, it looks like this, where for the horizontal alignment, it's on the left, and as well as the vertical alignment is on the top, like how all of these are, where the word types downwards as well. So first we want to change our H align to FA center. And then if we open up our vertical alignment, we can see it here, and it uses FA top, FA middle, and FA bottom. And if we want this totally centered in the screen, we want our vertical alignment to be this FA middle. So let's do that real quick. And pretty much every time I use these, I can never remember which one of these is supposed to be center and which one is supposed to be middle. So I open up that manual page a lot, actually. But now if I were to run the game, we should see that, yep, it is nice and centered. Okay, so problem 1 solved. And now let's just do another easy one, and let's set the alpha. And we can do that in the exact same way that we did draw rectangle color. So we can then draw set alpha. And this one, we're just going to pass in the regular alpha variable, because I don't want the letters to be ultimately see-through. I want the letters to be totally opaque whenever they show up. So I'm just going to use alpha by itself. And then I want to draw set my alpha back to 1 again, which if you look up here to our draw set alpha, we're drawing this black rectangle, and then we're drawing a word, which we already set the alpha to something else. So we're setting this 2 separate times by the time we do the next draw. So we actually don't even need this line of code anymore. It won't matter, just as long as once we're done setting all these to whatever values we want, we ultimately end it up back to 1. So now the text should fade in. Yep, it fades in, and it very nicely fades in at the exact same rate as the background, even though they end up at different opacities, because we're just using this one multiplicatively. So very nice. And now our last thing is the game over looks a little lackluster. It's a little small, so there are multiple ways we could mess around with this. First off is making a font and changing that font's size, but the other way is draw text transformed. And this lets us scale up our text in the same way we would like scale up a sprite with an X scale and a Y scale. See, we got an X scale, a Y scale, and we have an angle as well. The reason I really like using this is because normally I just make my own fonts, which is pretty easy to do. A lot of people seem to really not want to do that in the menu system and text box videos, but it doesn't take too long to make a simple pixel art font, and having it built into GameMaker, something about that makes me feel nice and safe, like everything's very precise. But so that's one reason I like to use draw text transformed. And otherwise, whether you're using an actual font in the draw event or you're using a font in a GUI layer, if your font's default size is really big, you can scale it down with draw text transformed, but you'll get weird little artifacts and it'll look a little strange. So that's also another reason that I like to use pixel-based fonts, is because they normally have like a minimum size, which is pretty small, and you can blow them up and they still look fine because they just look like pixel art. So anyways, draw text transformed. That text was pretty small, so I'm gonna make it like 5 times bigger. So 5 times bigger for the X scale and 5 times bigger for the Y scale. And then my angle is 0. I don't want it to spin around or anything like that. So now I can just run the game, and okay, it's certainly bigger now. But now we're kind of running into what I was talking about with scaling fonts in general. A font that starts out very low resolution is going to blow up at low resolution. And unlike a pixel art font, this is just a very low resolution font. So the anti-aliasing looks kind of weird like this. So Firstly, I might actually shrink it just a little bit in general. So maybe times 3. Okay, that's a good size right there. But anyways, now we're going to change the font. And if you want to have a really good looking pixel font, please watch my menu system video. It goes over how to make your own font in GameMaker. It's very easy. It's not difficult. You can just look up any pixel font you like and just copy it if you want, or you can come up with your own way to make them. You can copy mine from that video. It's very easy to make and very easy to set up. It just takes a little bit of time. You know, I highly recommend pausing this and watching the first part of that video really quick. You know, just watch up to the point where the first time we actually draw some text, so that way you can see how to store it in a variable, which is what you'll need to do whenever you create a new font and kind of clear it out. But like I said, it's not that hard. I honestly had more trouble finding fonts that I liked that were pixel art and that I made actually work in the draw event. So again, if you're really going for it, watch that video. If you're just worrying about functionality right now, then I'm going to show you how to just add a regular font into GameMaker. So that's also very easy. You go into your asset browser and right click, go to create like normal, and you just go down to font right here. And you see immediately some stuff filled out for me. We've got font 1 and we have a preview right over here. And basically what you can do is you can select a font on this drop down menu, and these are all the fonts that you have in your computer. So it's probably going to look a little bit different than mine. Your computer will probably have a ton of fonts in it already. You probably have stuff like Arial and its many different forms, and just honestly tons of other stuff. So you can look. But yeah, just click around and find something you like. And you can go online and find typefaces to download. This actually doesn't look awful. I kind of like this. I'm gonna say this is gonna be font Segoi. I might use this for fun. But anyways, I would suggest that maybe if you are going to find one to download, you maybe look for some pixel art fonts. So the type of file that you're looking for is a .ttf, which is true typeface, and you can just download those onto your computer and then install them, and then they'll be on your computer. One that a lot of you have probably just seen a bunch of times is 8-bit Operator. That's sort of just an old school computer font. Lots of games have used it. Obviously, Undertale and Deltarune are big ones that use it, but a bunch of other games have used it before. A bunch of older games use it. NES games and arcade games use this font or a font very similar to it. So you can find 8-bit Operator. That's a good one. It's probably not on your computer, but it should be very easy to find a free download for it. But like I said, I'm going to try out this font. And yeah, so now that you've chosen the font that you actually want, there's other stuff like the style, which depends on font to font. Some have different styles, some don't. Some different styles are just built into a totally different font. And then you have size, which, like I said before, is the size of your font. 12 is generally the default. And then you have anti-aliasing. So if you squint real hard, or actually I can just do this. So aliasing is the kind of translucent pixels that go around to, at a distance, smooth out a font. But if you zoomed in, they kind of look like this. And it's what was happening with our font whenever we blew it up for our game over. If I turn anti-aliasing off, this is what happens. So the font becomes pixel perfect, which can look a little funky for certain fonts. You see, like, you know, this doesn't look amazing, but that's when you can kind of mess around with the size of the font as well. So a lot of the reason a lot of this is looking really uneven is because the font is so small. So if I up the size a little bit, you see a lot of the letters that kind of had like a super thin single pixel line have kind of filled out a little bit more now. You see like the exclamation point is still kind of thin, so maybe go up another one. And yeah, it's not looking too bad. But yeah, you can, this is just another way that you can mess around with getting pixel sprites. Like I said, though, you probably don't want to make it too big, because regardless, what's going to happen is whenever you scale it back down, if you need to, you know, this is what's going to happen, and they're still going to all scrunch up. So yeah, you know, I'm kind of feeling this font. I'm going to try this at 13 size. And, you know, this would still be a pretty big font for pixel art. You know, so I'm going to try it at size 13 with anti-aliasing off, and then I'll show it with the aliasing on. We'll mess around with some other stuff, but really whenever you get into visuals like this, it's just a lot of tweaking and a lot of trying. Like I said, your best bet is probably to just download a pixel font. I might even go back to the 8-bit Operator before this is over, but let's just try this out first. So changing our font is as simple as using another draw set function. So we say draw set font, and then we put in whatever font resource that we have. So I have this one that I don't know how to pronounce. And if you made your own font, you know, and you watched my menu video, then you probably stored it in some global variable like, you know, global.font or something like that. But yeah, so that's how you set that. And like I said, that was a pretty big pixel font. So I don't really know how this is going to look at this scale. So this could look way bigger, or it could actually look a lot smaller. I don't know, but I think it'll look a bit bigger. But let me just run the game and let's see what happens. Okay, it's actually about the same size. And yeah, as expected, it looks a tiny bit messy because this font wasn't necessarily supposed to be pixel art. But since I know I can blow it up to be pretty big, I might just increase the size here a little bit, which might help out round out some of the edges a little bit. 20 doesn't look half bad. So now if I set that to 1, might even need to make it a little bit bigger again. Yeah, if I set that to about here, let's see. Yeah, not so bad. But I don't want to make it too big because if I want to type smaller text, then, you know, I don't really want to scale it down lower than its low size. I can with this code by setting it to, you know, 0.5 for half the size of something like that, but we'll just see how this goes out. Real quick, I'll turn on the anti-aliasing and we can just see what it looks like. So it looks smoother, but it kind of adds in, you know, weird looking pixels. This is all you. This is all your decision. I'm going to turn it off really quick. So I'm actually going to add another font just to show you the benefits of using a pixel font. So I'm going to use 8-bit operator, say font 8-bit, and I'll just leave it at that. Now, even this font actually starts out with anti-aliasing. You can see it. It's just harder to tell, but so I'm going to turn that off. And you can actually see the scaling isn't perfect. It still looks a little weird. So like, look at this V here, look at the M. So what you really need to do is, you know, change the size around to see what works the best. But a secret about pixel art fonts is because they're supposed to be lower resolution, they're actually probably supposed to be a lower size than 12. So I actually know what the size for this font should be, but if I go down, you see it still looks pretty weird. That looks even worse. If I go down again, it still looks pretty bad. If I go down again, looks pretty bad still, but not much worse than the first one. And if I go down again, oh, look at that. It's perfect. So yeah, the size of font that 8-bit operator wants to be is about 8. If I start going smaller, you see that letters start mashing together. And that's the good thing about pixel art fonts that you can find and download and stuff like that, is they work at super, super tiny resolutions, which means that if I wanted to type out some text with these, I could type out really small text. So I'm just going to set this to font 8-bit now. And now you'll see that even though I have my scale at 2 times, it's going to be way tiny. So yeah, look at that, much smaller. And that's double the resolution. If we put this, if we just drew it normally, so at 1 scale, we could draw text that small, which could be very useful for certain things, especially in, you know, you saw the preview, we're going to have game over and then we're going to have the press a button to, you know, end the game. So if I wanted to make my game over text big, I could just set that to a high number like 5. Pretty good. And then I could set my other text to something smaller. So let's add in that other text. And luckily for us, all these settings, we're just going to keep on keeping on. So I'm going to keep this as the 8-bit font right now just because I can, and then I'll swap back to the other one and show you another example with my other font. So I'm actually just going to move this comment down here and put all these settings up here, and down here I'll say reset the alpha. And so any more text we need to draw, we can draw over here too. So now we're going to say press shoot to restart. That's what we're going to say down here. So we can basically do the same thing. So draw text transformed. And now we want both of these to kind of be in the center of the screen, but you know, we kind of want them to make room for each other. So maybe I don't want game over to be exactly in the middle of the screen anymore. Maybe I want to bump it up a little bit. So maybe I want to add a variable that's called game over offset. And we'll just say that's negative 32 pixels because we want to scoot the game over up on the screen. So I can just add this value into my Y section down here because this is all the Y value, and that'll scoot it up a little bit. So I'm going to comment this out just so I can test that before we move on to the next one. So if I run it now, it should be, yeah, it's up a little bit more. So now it's not totally centered. So that's good. You'll see here especially whenever you're programming visual stuff like this, you're going to start having a lot of variables and a lot of local variables. And also all of these things are going to require just running the game and testing it a lot of times, just so you can see where everything is and get a better feel for it. So anyways, now we can move on to our next text. And first we can start off by drawing it in the middle of the screen, just like how we did the other one. So cam X plus half a width, cam Y plus half the height. Oops. cam Y plus half the height. And then we want to add an offset to this too, because we don't want this to draw right in the middle of the screen. We want it to draw a little bit lower. So we can say this is going to be var restart offset. And let's push this one down a little bit farther into the screen. And so let's say that'll be like 80. So down 80 pixels from the center. So let's add that to the Y value. So add our restart offset. We want to draw our text. So we could say press shoot to restart. And if we wanted to, I don't know, we could add just some little marks around it just to look nice, like parentheses or just little dashes, or, you know, these little guys right here, these little squiggly guys, just for a little bit of a visual flair. And then our scales. So 1 was actually pretty small, so I might even want to do 2 for these. So that's nice. And 0, we don't want it tilted in any way. So run the game and check. Not bad. Not bad at all. I think this text is a nice, good size. I like the way this looks. So, but I don't really like how they're like balanced out with each other. So maybe I'll make this top one a little bit bigger. So maybe I'll make it 7 times larger than it's supposed to be. Okay, that's pretty cool. That's not bad. It's still a very simple game over screen, but I kind of like that. So cool. And like I said, at this point, I have a little bit of an intuition about how what number of offsets are going to work. And I also have my old project over on my other screen over here, so I know what numbers I picked before. But yeah, let me just basically reiterate, anytime you're programming visual stuff like this, it's going to take a lot of testing and just making educated guesses and then seeing where you need to tweak from there. So, and just for fun, really quick, I'm going to comment these out and I'm going to try and see how I can get my other font to look just super quick. So I'm going to draw just like we did before, but I'm probably going to make that maybe 4 times as big, I'm guessing. And then this one definitely needs to be 1. It might even need to be like, 0.5 or something like that. So I'm guessing these offsets are probably too small, but let's just see how that looks with my other font. Hey, actually, you know what? I don't think that looks half bad. Maybe this is too big. Maybe I only want to do 3 for this, or maybe 3.5 or something. But let's see here. You know what? That doesn't look half bad either. In fact, I kind of like it. Let me just see how that looks with the anti-aliasing. The bottom text will probably look a little bit better than the top text does. Yeah, not bad, but that's not my bag. So okay. So I'm turning it back off. Okay, not bad. And something that I did forget to mention, which hopefully I added it in a little note in the video, is your viewport size when you first run the game actually changes the resolution of the game, technically. And it kind of creates this effect where, let me show you. So really quick, I'm just going to get rid of my game over object, and I'm just going to show you on my player up here and stretch out this wall so no one can beat me up. So right now, my viewport is about 2/3 the size of my screen. So it's at 720p. If you look at the rod that I'm shooting, and I'm sure you've noticed this already, but if you look at the rod, you can see it's a little jaggy, but it's not actually fitting pixel perfect into the resolution of the actual game, right? So you can see that. So now here's what it looks like at both an even smaller window. So now the window actually matches with the resolution size of my game. So it's only taking up 1/3 of my screen. And here it is whenever the window is basically the same size of my screen. And so you can see the difference. The game actually is running at a higher resolution in the 1080p window versus the window that's only 640 by 360. So this will kind of affect how your fonts look in the draw event as well. But it's only really going to affect them if you start using multipliers that are lower than 1, especially if you're using a pixel art font or a font with no anti-aliasing, or you're scaling it up to like a weird number like 3.5 or 3.7. But normally by the time you're blowing it up that big, it's not going to look super weird. So yeah. Okay, so having said all of that, going over all the font stuff, pretty much done with our draw event. And if we want to, kind of like how we reset our draw set alpha, we can reset these 2 settings as well. So I'm just going to say reset draw settings. And if we remember, the default for our horizontal line is left, and the default for our vertical line is top. That's not really important. In general, whenever I draw text, I like to set the horizontal and vertical line before anyways. And these functions only affect how text is drawn. However, sometimes it's easy to forget, so I just like to reset them whenever I'm done as well. So yeah, that's it. So we have the visual done for it, and now we just need to do this part, right? The press shoot to return. So we would need to do that in our step event. And what we need to check for is our shooting key, right? Well, if you remember, we set shoot key over here in the player's step event. Now we could just copy and paste this shoot key input and paste it into here like this. However, as you make more objects and more systems for your game, you're gonna have more objects looking for the player's inputs. So now is a good time to sort of abstract this stuff out into its own input object. And we can make variables like these global so any object can reference them. So let's do that. We're gonna create a new game control type object. And so I'm gonna right click and create, and I'm gonna call it just O input. I've done this for other videos, so it's gonna work the same way. But if you didn't know, basically what we're gonna do is we're gonna make an object input, and we are going to make it persistent. So that way, you know, it stays in all the rooms. That means that before we test this, we're gonna have to put it in our initialization room. But what we're gonna do in here is we're gonna set up some global variables and track them in basically the same way that we're doing it up here. So first, let's create our input global variables. And I want to get these inputs, right? So I want to get the right key, left key, up key, down key, shoot key, and pressed key. So let's just set them first. So global dot right key equals 0, and we're just going to be setting them like this. So global dot left key equals 0, global dot down key equals 0, and so on. And we're just going to do one for each of these. So I made a global version of all of those, just like how they're set up in the player event. And we're going to be setting these global variables in this exact same way, just in our object input. So we're going to add an event. And we're actually going to add a begin step event. So add a begin step event, which, as I explained with the end step event earlier, a begin step event, just every single object runs their begin step first, and then they all run their step event, then they all run their end step. So that way, whenever we're getting these values, if any other object is checking for these inputs in a regular step event, they'll be properly getting the input on the same frame that GameMaker recognizes it. So like I said, we're just going to do this same exact code up here, but we're going to do it for the global variables. So I'm going to cheat, and I'm just going to copy this and paste it, and then I'm just going to type global dot in front of each one of these just to save a little time. So again, obviously this is getting the inputs in the exact same way, except now that they're set up in global variables, I could do like this. So I could say our player's right key equals the global dot right key, the player's left key can be the global dot left key, and so on and so forth. So now the player is just reading it from the object input, which is doing the exact same thing. So once again, before we do anything else, let's test it real quick. First, we need to add our object input into the game, and we need to make sure it's set to persistent. So it's persistent. We go into our room initialize and drag an instance of our object input in here alongside of our camera. And so now if I run the game, it should still be working fine. I think the game over is still going to show up. Yeah, okay, but I'm still moving around fine, and all that's good. So good. That's working. Now, if we decide to change what the shoot key is, or if we decide to change this from WASD to arrow keys, any object that's getting an input will get the updated key correctly. So now up here we can get the shoot key input, and we can just say shoot key equals global dot shoot key, like that. And now what we want to do is we want to check if the shoot key is being pressed, and that will have us restart. And as far as the level goes, just resetting the room is going to be fine for restarting. So we can say this is going to be where we restart. So let's say if we're pressing the shoot key, and we want to say if our alpha is greater than or equal to 1, because we want the fade to finish before the player can restart. So they just have a second of it fading in and saying game over. And once that's done and we're pressing the shoot key, then we can call room restart. And that's what it does. It just it basically loads the room again, which for us is just essentially restarting the level. And if you wanted to have a really old school game over, you could do game restart. And game restart would obviously just hard reset your entire game. So that would be very old school. But yeah, so this should work. So if I run the game, I'm gonna move down here, and then I'll die. So, okay, the player's dead, player's gone. Game over is fully faded in. So if I click the shoot button, yep, look at that, it resets. And I can keep resetting it. If you hear me clicking, it only resets once the game over is fully faded in. Okay, cool, nice. And just a side note, we don't have to store global.shootKey in its own variable. We could just reference it all together like that. That would work too, especially in this code. The main reason that I stored it in the player is because the player was already using variables to reference the rest of the step event. But also, I mentioned this before, referencing a global variable is a little bit slower than referencing an object's own variable. So if you can just store that global value at the top of a step event or like in a local variable or something like that, then if you need to reference it multiple times in a step event, then that's just a little bit better. So cool, now our game over screen is actually just completely functional. That's it, it works. So now we just need to not have it sitting in our room, and we need to create it whenever the player dies. So that's easy. So first I'm gonna go into the room and just delete it from inside the room because we don't want that one in there. And then we can go into our player object, and we can go down to our game over code. Let's get over here. Go down to my death or game over. So we destroy ourselves, and right before we destroy ourselves, let's create the game over object. And it does not matter where we create this, so we can just say instance create depth. Literally doesn't matter where. So 0, 0 is fine. The depth also technically doesn't matter because we are setting the depth in the create event of our game over object anyways, but so you could set it to 0. You could also go ahead and set it to that negative 10,000. It doesn't matter. It's going to end up being that negative 10,000 anyways. And then we're going to create our object game over screen. So that should be it. And since our player is getting destroyed right here, then, you know, we're only creating one instance of it. So that should clean itself up nicely. So good, it's not here. Can move around, shoot, do some stuff, get hit. And if I get hit again, there we go. Game over screen. And if I press the shoot button, yep, and we're back. So great. A simple little fail state that resets the level that we're on. And, you know, as far as this game goes, a single room is going to be a single level. So nice. Very, very nice. We now have a fail state. We now have enemies that we can beat up. So as far as just pure interactivity goes, we have a video game. So great. But before we move on to anything else, now the player can take damage and die, and the game over screen happens, and we reset. Now let's just have a little bit of fun cleaning up the way our health is represented for our player. Because I'm getting pretty tired of this ugly little number hanging out at our player's feet like that. So yeah, let's get rid of that and do something nicer looking. Okay, so let's start working on a HUD. Now let's go ahead and create that HUD. I'm gonna close my player, and this is gonna be another game controller. We're gonna make an object that is gonna handle all of our HUD drawing stuff. I found it can be very difficult to keep track of a HUD if it's being controlled by multiple different objects. So I tend to do this nowadays. So right click, create my object. I'm just gonna call it O, HUD, like that. And let's go ahead and set its depth, because remember that's going to be important. So this needs to draw on top of a bunch of different stuff, but we want it to show up under stuff like the game over screen. So the game over screen was negative 10,000, and that's probably one of the only things we want to have show up on top of this. So the depth for this could be like a negative, 9,000. And we can just say, make sure this shows up on top. So cool. First thing we were talking about doing is going to be the player's health. And so we can add in some variables to keep track of the player's health like that. And we can have one called player HP, and we'll just start that off with being 0. And we can also have player max HP. So if we want to grab these variables from the player, then all we need to do is go into our step event and get the player's HP info. Oops. And the only way we're going to be able to do that is to check if the player actually exists, right? So if instance exists O player, then we can copy the player's max health and health into our variables for this object. So our player HP equals O player.hp, our player max HP equals our O player.max HP. Easy. So now we have that info, and we can draw it somewhere. So now we're going to add our draw event. And since we're drawing all this stuff to the screen, we do have to get all of our get cam coordinates. We got to get our camera stuff first. So let's do that how we always have. So all we're getting first is the X and Y. So storing camera get view X in cam X and get view Y in cam Y. Very important. And before we do any visuals, let's just go ahead and draw the player's HP. And we can just do that with a very simple line of code. So let's just draw some text at a certain position. And right now, let's just draw it at the top left of the camera. So the left would be X and the top would be Y. Simple enough. And then we can write out our HP variables, which, I've already showed you how to do string for HP or anything like that. So let me show you how to make a slightly more complex string. So I'm going to store it in a local variable and just call it HP string. And here's something cool that you can do with strings. You can actually add them together. So if I said we had the string hey, I could also add folks to that, And that would be the same thing if it said, hey, folks, like that. That's the same. So that'll help us over here. So first I can just like write HP with a colon. Then I can add the string for the player's HP. So the player HP. Then I can add a / to show that it's out of a hole. And then I could add the player's maximum HP. So player max HP, like that. So altogether, since our player's HP is 2, that will ultimately come out looking like that. But it will change dynamically based on how much health the player actually has. So let's just plug that string in really quick. Now this should draw pressed right up to the top left of the screen. We're mostly just making sure we can get a visual going and that we're getting our player HP variables correctly. So now we just need to put it in the game to test it. First of all, much like our input object and our camera, our HUD is something that's going to be important for the entire game. So that needs to be persistent. I'm going to scoot it up here. So it needs to be persistent, and we need to go into our initialization room and drop in an instance of our HUD. So you see left, we got a camera, our input object, and our HUD now. So we should be able to run it and see the player's HP at the very top left of the screen. Yeah, look at that. And so I got hit and I lost one. And now if I got hit again, oh, right. Well, it didn't have enough time to update to 0 out of 2. But if we wanted to, we could go in the step event and say, if the player doesn't exist, we can just automatically set the our player HP variable to 0. That's not super important, but another thing that I failed to mention is obviously the font changed to our new font whenever we set it over here. Because like I said, those draw set functions make permanent changes. So whenever the game over screen shows up and we set the font to this one, then anything else drawing with text is going to be set to this font unless we, set it manually. Not really a big deal though, because we're not going to keep it this way. We're going to have a cool little health bar that looks really nice. I just wanted to make sure that we had our HUD working, and we now have confirmed that our game over screen does in fact go over our HUD, which is what we wanted. So good. Now I have a little visual for the health bar. So let me add in that sprite and let me show it to you. Okay, so I've added in my health bar, and this is kind of what it's going to look like. Now it looks a little goofy because it only has 1 notch of health, but let me show you really quick what it's supposed to end up looking like. So I'm just going to change this with something really ridiculously tall. So what we're going to want to do is we're going to make a health bar that can dynamically change based on how much maximum health we have and how much, and shows us how much health we have. So what it's going to end up looking like is more like this, where we have multiple notches of health, and then anytime we lose some health, these notches go away like that. And the way we're going to set it up so it works with the max health being any number at all is we're separating them out into this one little piece like this. And you see that here in one of these sub images. I'm going to go ahead and crop my frames back down. So we're going to separate them into these 2 images here. One is a health notch like this, and one is a blank space. And actually, I need to make this bigger again. Oops. Okay. So the principle is going to be, we are going to take one of these 2 images right here, and we're going to keep drawing it on top, going to the right. So if I add like a gray color just to show you better. So we'll draw this first one here like that. And then if our maximum HP is say 5, we'll go over a few spaces, then draw a new one like that. And then we'll go over and draw a new one like that. And then another new one, and then another new one. And so you can see this is going to be a super easy way to sort of dynamically change the size of our health bar how we need to. So now I'm going to resize these back to where they need to be. And we're even going to be manually drawing this first little notch here in our code. So it doesn't really even need to be on this first frame since it's going to be covered up by either a blank one of these or a filled in one of these. But basically, if you want to make a health bar like mine, first you want to come up with, whatever kind of HUD image you'd like to have. So I just picked like the head of my player. I thought that looked nice. And then a part that you can keep tiling. And you can do this simply as well. So for instance, let's say that you just want your health bar to just be a bar and you don't want a picture with it. Then your left part of the head here could literally just be this right here. And so then you would make pieces that again looked just like these, and you want to put them in the same position that the first one is in, so that way they can draw on top. And now if I draw the first one, I would draw it here, then the second one here, and the third one here. So hopefully that's all making sense. So yeah, we don't even really need this first notch, because we're going to keep drawing them out, and we're going to use a for loop, which is, you know, pretty much the easiest way to loop through stuff a certain number of times and draw something down for it. So let's just go ahead and do it, and we'll see it in action. So yeah, we got something like this, and I'll show you where I put the origin. Since I want this health bar to show up at the top left of the screen, I put the origin in the top left of the image, so I could just scoot it in a couple pixels in code, and I can very easily visualize exactly where it will be. So if I say draw 4 pixels down from the top of the screen and 4 pixels to the right, I know that that means there's going to be, you know, 4 pixels worth of space here and 4 pixels worth of space here. So let's do that in our HUD. So I'm going to go to my object HUD over here, and I'm going to get rid of this drawing the player's HP as a string because I'm not going to use it anymore. Now I'm going to draw my sprite health bar. So let's take it one step at a time and say draw sprite. I'm going to draw S health bar, and first we want to draw the little the left side of the health bar, which in my case is the icon with the player's head in it. So that's the first image that we have there. And then we want to draw an X and Y position. We can draw at our X for our camera and our Y for our camera, like that. And before we do any more health stuff, if we just run this, we should be able to see it, yeah, wedged up in the top of the screen there, way up there. And I don't really want it touching the sides, so we can add in like a little border for how far it should be out. So let's exit, and we can add that in a local variable, because we probably want it to be equidistant one way or another. So I'll say var border, and I'll say 8 pixels is probably going to be pretty good. So we want it to go 8 pixels off the side of the screen from the left. So add our border into that, and we want it to go down from the top of the screen. So we'll also add our border to our camera's Y value. So if I were to run the game again, yep, that looks better. Okay, cool. So now we can start drawing stuff outwards from it. And I think I'm also going to make my my window bigger so it's easier for you guys to see. So I'm going to do that really quick. Okay, there we go. That's a little bit easier to see. So cool. So now we have that left side all good. Now we need to actually loop through and draw each individual tick of health. So first let's set up that loop, and that's going to look like this. We're going to say for, we're going to say var I equals 0 to start off our loop. And we're going to loop as long as our I is less than our player's maximum HP, right? Because we want to draw a tick for every single bit of the player's max HP. Because even if the player is down some health, we still want to draw an empty tick. So we're looping through all those, and we're just adding one to I, so that way we're properly progressing through the loop. And again, let's do it step by step. So let's start with draw sprite. We're drawing from our sprite health bar, of course. Now our sub image is going to be determined by whether or not we have enough health, but let's just go ahead. So it would be sub image 0 is the left side of the HUD, sub image 1 is going to be an empty tick, and sub image 2 is going to be a full tick of health. So let's just go ahead and start with 2, just so we can visualize it properly. So we're starting that at 2. We're drawing it in the same X position, because if you made your sprite like I did, where you see all this space that's left here, if I turn on the onion skinning, you can see they're already placed in the correct first position based on, you know, the left side of the HUD. So if you did it like I did and you had this part of the HUD, you know, attached over here, and then the way you made the second parts is you just copy and pasted that and got rid of the HUD like this, then you're already in the right position for at least the first loop. So we're just starting in the same X position, but then we need to go to the right every single loop. We shouldn't be drawing all of these in the same exact position. We need to draw them like individual notches. So just depending on how you made yours, I can show you here. So here's where one would be. So if I wanted to make it look even, I would need it to go 1, 2, 3 over, and now they look even. And so I would draw that one there, and then I would draw the next one 1, 2, 3. That's how much space we need to go over for each loop. So let's add that as a local variable real quick, and we'll call it var underscore sep for separation. And that's going to be 3 pixels. So we're drawing at our X position, and we're drawing at our separation times the loop that we're on. So separation times I. And that will make sure that every time it draws a new one, it draws it 3 pixels to the right. So that's good. And its Y position is already in the correct place. So the player's max HP is only 2. So just to show a higher number, I can go ahead and change this to say 5. So now our player's maximum HP should be 5. And whenever we draw, that's what we should see. Uh-oh, spaghetti-o. I didn't do that right. So let's see what I did wrong. Oh, oops. Okay, that was a dumb mistake of me. We're not supposed to be drawing based on our HUD's X and Y position. Obviously, we're supposed to be drawing it based on these X and Y positions, the same as the sprite health bar. Sorry about that. Been recording a while, I'm getting a little scatterbrained. Okay, so instead of X and Y, we need to do cam X plus our border, and we need to do cam Y plus our border. And another thing is, the reason that this first one showed up is because I copied this over here and didn't get rid of it again, so I don't need that anymore. Okay, and I just hide those walls. Don't need those up there anymore. So now we should be able to run, and there we go. We got 5 little things up here. Okay, so now it doesn't reflect my health. See, I just got hit. I technically have 3 health down here, but up here it still says 5. So now we just need to change this image based on whether or not we actually have enough HP. So let's make another local variable, and we'll call this show current HP. And this local variable will be _image, and we'll start it off at image 1. So image 1 is our empty notch. So if we plug in image right here, it will now show 5 empty spaces. So we see that up here, 5 empty spaces. And what we need to do is check whether or not that certain notch should be drawn, and that's very easy to do. We can just do that by comparing which loop we're on with the amount of regular HP we have, not max HP. And we would do that like this. We would say if I is less than or equal to HP, then we can change image to be 2, which means that that notch should be filled in. And one more thing that we want to do is compensate for the difference between how I is counted and how HP is counted. So because we're starting our loop at 0, we just want to add 1 to our HP, because for the first tick that we're drawing, that's technically 1 HP. And then the second tick is 2, and the third tick is 3. So if I didn't add this, this is what we would get. Draw, and oops, okay, so object HUD.HP has not been set before reading it. Oh, of course it hasn't, because this variable is supposed to be called player HP, not regular HP, because remember, we stored it in these. Obviously, Peyton, think. Okay, so anyways, if we didn't compensate by adding 1 to our I, here's what it would look like. You see, I just took damage, and I now have 4 health, but I still have 5 ticks up here. And if I took another piece of damage, now it's off by 1 again. So that's why we need to add to I, because it's kind of under checking right now. So if I add the 1 back to I and we run the code, now I have 5 ticks. I get hit, I have 4, and then 3, 2, 1. Oh, well, I lost both of those at once because I was touching 2 enemies at one time. But yeah, so that's it. That's it working. And now I could go into my player and I could change my maximum HP to say 20 if I wanted to. I could run the game and look at that, 20 HP. Looking great. It does look a little wonky, but that's only because, like I said, I have my window huge right now, and my window is technically being scrunched up because it's not in full screen mode. But trust me, it's working. This is what we want. So awesome. That means I can go into my player now, and I can get rid of this ugly little number. So go into my player, into my draw event, get this HP as a number heck drawn out of here, and run the game. And look at that, nice and clean health bar at the top left of the screen. You love to see it. Awesome. Okay, and so one last thing is maybe you don't even want to draw the player's HP if they don't exist. Because remember, this HUD is a persistent object, so you know it'll also be around in your title screen and stuff like that. So if you don't want this HUD drawing that player health in like a title screen or something like that, or you only want it drawing whenever the game is being played, first of all, you can check for rooms. So you can say if you have a room called like room title screen or something like that, you can just check here and say, you know, if the room is not equal to room title screen, then draw it. Or an easy one is just if not instance exists player, then don't bother drawing this. So when the player dies, that means that the HUD will technically go away too. At least, you know, the player's HP will go away, but you know, does that really matter when the player's dead? Anyways, there's multiple ways to figure this out, and there's multiple ways to check whether or not you should be drawing it. So that's up to you. I'll just go ahead and leave it as only draw it if the player exists. So yeah, cool. Now our player health looks great, and we have a HUD object that we can use to draw a bunch of different things. And that'll come in handy next, because now we're going to move on to making enemy spawners, so enemies can keep coming, and also adding a way to make sure that only so many enemies can be active at once, and maybe there can only be so many enemies per room, which would basically be like, you know, the way I had it set up was there are 200 zombies per this room, and once you beat that room, you've technically beaten the level. So that's another good thing to have on an enemy HUD is an enemy kill count, or a score count, or something like that, which are basically the same thing. So let's get into the enemy spawning stuff now. Okay, thanks again for watching. Don't have much to say, so I'm just gonna give my big thanks to my patrons on Patreon. Thank you so much, Nixionic, Red Dragon Redemption, Null, Joseph Sandlin, Midnight, Jerica Deloach, Mark, Aogio, Homeless Bums Ahoy, Skelenthrax, Captain Ludwig, Christian Donovan, Nick, and Crunch Sting. Thank you guys so much, and thanks so much to all my other patrons, and for you for watching. And one last thing, I normally record these intros and outros right before I finalize the videos and put them up. So the Patreon credits and shoutouts will be updated pretty much in real time. And I'm not going to be able to do that for the next two. So I'm just going to have to do the next two videos right now and schedule them to be uploaded at the correct time. So just so you know, for the next two, they won't be updated if you happen to join the Patreon by then. But if you do join the Patreon right whenever you're seeing these new, then it will work out that your name will be in the following video after those. So, yep, just thought I'd let you know. Okay, well, that's all. See you next time.